our discussion. So let us start our discussion. I hope you all can see the screen. So as I said, the topic for the discussion is motion of a charged particle inside a magnetic field. Let us try to explore this. Let us say we have a charged particle of charge q, mass m, which is shooted with a velocity v bar inside a magnetic field of induction b bar. So there is a charged particle of charge q, mass m, shooted inside a magnetic field of induction b bar with a velocity v bar. Then that charged particle will experience a force given as F bar is equal to Q into V bar cross B bar. Let us take it as QVB sine theta into N cap. So here, force on the charged particle is QVB sine theta into N cap. This N cap will give you the direction of force. N cap gives the direction of force. Gives the direction of force. Okay. How to find out the direction of force? That is direction of N cap. To find the direction of N cap, we use right-hand thumb rule. We use right-hand thumb rule. Meaning is, you have to stretch all your right-hand fingers, except the thumb. You can clearly see, I'm not opening the thumb. I initially kept my thumb closed. All other fingers have stretched. You have to stretch all other fingers in the direction of B bar first and close them towards B bar. That is, you have to stretch them in the direction of velocity vector, except the thumb, remaining fingers, close them towards magnetic field, then open the thumb. Then the thumb will give the direction of force. So I repeat again, first, except the thumb, stretch all your right-hand fingers in the direction of velocity vector, close them towards magnetic field, then open the thumb. It will direct to the direction of force. Example, if I say, if I take an example, let me take velocity vector is along k cap. Magnetic field is along I cap. Then N cap will be in the direction of V bar cross B bar. That is nothing but in the direction of K bar cross I cap. K cap cross I cap. So let us try to find out this direction by using right-hand thumb rule. Now, the direction which I'm facing, I'll take it as I cap. Then my head is on the K cap. My left-hand side is on the J cap. My right-hand side is on the minus J cap. Back side of me is minus I cap. And my feet is minus K cap. I repeat again. I assume that I'm facing I cap. Then back side of me is minus I cap. My head is K cap. Legs are minus K cap. Left-hand side is J cap. Right-hand side is minus J cap. Now what we have? K cross I. So first I have to stretch all my right-hand fingers in the direction of K cap. in the direction of k cap. Can you see it? I think you can clearly see. All my right hand fingers except thumb is stretched in the direction of k cap. Now I have to close them towards what? Towards the direction which I'm facing, because that I have taken it as I. Magnetic field is along I. So I closed it towards I. Then I'll open the thumb. Thumb is pointing towards my left hand side. Thumb is facing towards my left hand side. So the meaning is it is J cap. So force is along J cap. I think you understood how to find out the direction of force using right hand thumb rule with this particular example. So going ahead. So basically the force we can take it as F is equal to, or F bar is equal to QVB sine theta into N cap. As N cap direction is used using right hand thumb rule, we can find the direction of N cap, and this part will give you the magnitude of force. Magnitude of force. So let us try to examine this magnitude of force. Right? So we will try to examine this QVB sine theta. Right? In this, the first point, let me take theta is equal to 0 degree. Meaning is force becomes 0. There is no force acts on the particle if it is shooted parallel to the magnetic field. Number 2, if theta is equal to 180 degree, in that case also force will be 0. Anti-parallel to magnetic field, in that case also force will be 0. Third case, let me take theta is equal to 90 degree. In this particular situation, your force will become QVB. Force becomes QVB. Meaning is force is perpendicular to magnetic field as well as velocity. Meaning of this is F is perpendicular to velocity and F is perpendicular to magnetic field. Meaning is this particular force will provide centripetal force. Centripetal force. As the force is perpendicular to velocity, you can take it as centripetal force, because of which the particle moves on a circular path. Particle moves on a circular path. Let me say radius of that circuit is R. Then you can write mv squared by R is equal to QVB. mv squared by R is equal to QVB. From this, I can write R is equal to mv by QB. And V by R is equal to QV by M. V by R is equal to QB by M, which can be taken as omega, angular velocity. Time period T is equal to 2 pi by omega, so which will be taken as 2 pi M by Q. So for theta equal to 90 degrees, we can conclude it will move on a circle of radius R is equal to mv by QB. It will have an angular velocity of QB by M, and the time period is 2 pi M by Q. So this would be the situation if velocity vector is perpendicular to magnetic field, that is theta is equal to 90 degrees case. If theta is equal to 90 degrees case, these are the situations that we get. I think you are clear with the things. So this is an important thing which you have to make note of it. We'll be using it very often. Radius of the circular path is mv by qb. Angular velocity is qb by m. Time period is 2 pi m by q. I hope you understood up to this. The next important point you have to know is about what is the effect of this force on the speed. Magnetic force F is equal to QVB sine theta. This magnetic force F is equal to QVB sine theta This does not change speed. Does not change speed. It will keep the speed always constant. Does not change speed. It does not change the speed. It never changes the speed. It will change only the direction. Magnetic force will always change the direction. Fifth point, what you can say is F is equal to QVB sine theta can change only direction. Can change only direction. Can change only direction. It cannot change speed. So there is no change in kinetic energy due to magnetic force. There will be only direction change due to magnetic force. There won't be any change in speed due to magnetic force. I hope up to this you understood. Let us try to take few special cases. Case number 1. Theta is equal to 90 degree. Then magnetic force is, as we discussed, QVB. And radius R is equal to MV by QB. Omega is equal to QB by M. And of course, time period T is equal to 2 pi M by Q. So in this case, let me assume like this. This is your y-axis. This is your x-axis. Y-axis, x-axis. And there is a magnetic field B bar. Let me take is equal to B into the plane. That is B minus K cap. We have a magnetic field into the plane of the paper. Now, a charged particle of charge Q and mass M is shooted from here with a velocity V. Right? Its charge is Q, mass is M. Right? So velocity vector is V I cap. So it is shoot at a velocity V bar is equal to V I cap. So how does it move? That analysis we'll try to do it. So listen carefully, please. Now, velocity is along I cap. This is how I've taken, or this is how I've taken. Anything is fine. The direction which I'm facing. This is how I've taken. Right? V bar cross V bar, magnetic field downward, open the thumb, it is along J cap. So force is along J cap. So when it enters the magnetic field, here it is entering the magnetic field, it experiences a force in this direction. Velocity is along x-axis, magnetic force is along y-axis, hence it will change its path and it starts moving like this. After some time t, suppose say it is here. It is moving with a velocity v at that instant. Let me say, at that instant, it is moving with a velocity v. Like this, in this direction, along the tangent to that particular circle. Right? So force will be like this, obviously. So this would be the 90 degree, because velocity is supposed to be perpendicular to the force, as theta is 90 degree. Right? So earlier it was traveling along x-axis. Now it is traveling at some angle to the x-axis. Let me type that angle to the x-axis as theta. If this angle is theta, then clearly we can say this angle is also theta. So particle will be moving in xy plane on a circle. Of radius what? Of radius mv by qb, and of omega what? qb by. I hope you understood what would be the radius on which it is moving, what would be the angular velocity with which it is moving on that particular circular path. Right? So at this instant, angle through which it got deviated, this theta is what we call as angle of deviation. Angle of deviation. This theta is what we call as angle of deviation. And that theta can be taken as omega into t, because the theta is also taken as angular displacement in given time t. angular displacement in given time t. Now, this is its displacement along x-axis, I can say. This is your x, and this is its displacement along y-axis. That is your y. Now, how can I find that x? This is r, radius, I can say. Perfect. So this total is also the radius part, r. Therefore, my x will become r sine theta, perfect, which can be taken as r sine omega t. And my y becomes r into 1 minus cos theta. You can clearly see that y r into 1 minus cos theta. Because this center O to this point, it is r cos theta, and this total is r. So r into the point P, it is r into 1 minus cos theta, which will be r into 1 minus cos omega t. I hope you are able to follow the things. Now, I wanted to take the velocity along x-axis, component of velocity along x-axis. Vx is equal to dx by dt, which will give me as r omega cos omega t. And Vy, velocity along y-axis, is r omega sine omega t. So this is how I can find the velocity vector along x-axis, velocity component along y-axis. Anyway, speed is constant. That is root of Vx squared plus Vy squared will give me V only. And that angle theta is angular displacement, you can say, or it is the angle of deviation, you can say. I hope you are understanding. Now, I wanted to find out the distance traveled in this case. How to find out the distance traveled? How to find out the distance traveled? D is equal to, we generally use distance traveled as integral of root Vx squared plus Vy squared dt. Because integral of root Vx squared plus Vy squared will give me speed. Speed dt will give me small distance. Integral of that will give me the total distance in a time 0 to t. So using this integral 0 to t Vx squared plus Vy squared under root dt will give me distance traveled in a given time t. So you can clearly see here, if theta is equal to 90 degree, how much force is acting on the particle? How much force is acting on the particle? And what is the radius of the circular path? What will be the angular velocity? What will be the time period? How does the particle move after a time t? How to find out its displacement along x-axis? How to find out its displacement along y-axis? How to find out its distance traveled? Its velocity vectors are velocity components along x and y axis. So this would be the case if theta is equal to 90 degree. Sir, if theta is not 90 degree, then what will happen? That part also we'll try to see. If theta is not 90 degree, then what will happen? For theta less than 90 degree, what exactly will happen? We'll see. For theta less than 90 degree, what exactly will happen? We'll try to understand this. Right. Now, theta less than 90 degree means, let me take an example like this. Let me take an example. Like what example I'll take? I'll take my magnetic field is along B I cap, and velocity vector is making some angle with x-axis, projected at an angle theta with x-axis. V bar is equal to V at an angle theta with I cap. That is, this is your y-axis, this is your x-axis. Listen this part carefully. This is your y-axis, this is your x-axis. Along y-axis, we have our B bar, which is equal to B I cap. And velocity vector is in this direction. It is projected with a velocity V in this direction. at an angle, suppose say theta, this theta is some angle alpha, projected at an angle alpha. Theta is here, this theta is nothing but angle between V bar and P bar, velocity vector and magnetic field. Not the angular displacement which we discussed here. This theta is different from this theta, sir. This is the theta angle between velocity vector and magnetic field. This angle theta representation, I have taken it for angular displacement. These two theta are not same. Please don't get confused. This theta is different from this theta. Okay. Now back to here. Same way, here theta is the angle between velocity vector and magnetic field, and alpha is the angle made by velocity vector with V bar. That means this alpha itself is the theta, I'm assuming. If you understood, I think. Alpha itself is your theta. So angle of projection is alpha, or angle made by the velocity vector with magnetic field is alpha. Right. Now, we will further continue. In this case, your velocity can be resolved into two components. Velocity can be resolved into two components. In this direction, V cos alpha. In this direction, V sin alpha. Now, V cos alpha is parallel to V bar. No force because of this. No force. But V sin alpha is perpendicular to V bar. There will be a force. How much force will be there? That force is equal to Q B V sin alpha. This is a force, and in which direction this force is there? That also we have to try to find out. Now, V sin alpha is along y-axis, and B bar is along x-axis. Try to understand. V sin alpha is along y-axis, and B bar, that is magnetic field, is along x-axis. So, J cap cross I cap we have to find. J cap cross I cap. So, J cap cross I cap will give me what? This is my J cap. This is my I cap. Okay. Or this is my J cap. This is my J cap. Otherwise, okay. This is my J cap, sorry. And cross I. And thumb is opened and thumb is pointing towards my legs. That is nothing but it is along negative K cap. Meaning is, listen this part carefully. Meaning is, particle moves on a circle. Particle moves on a circle with plane of circle as y and negative z. So what is the plane of circle? Y and negative z. So in y and negative z, it will be moving on a circle. Also, because of V cos alpha, it will be drifting along B bar, that is along x-axis, comma. Particle even get drifted. Particle get drifted even along, get drifted along x-axis due to V cos alpha. Particle get drifted along x-axis due to V cos alpha. So there will be a circular path as well as there is a drifting. Now you can see one diagram over here. Particle is shooted in XY plane with some angle. This angle I was talking about is alpha. Right? So what is happening now? Outward it is z-axis, you can see. So into the plane it is negative z-axis. There is circle and you can clearly see the plane of the circle is in y and negative z. Whereas the particle even moving along x-axis, that is even moving parallel to B bar due to V cos alpha. So it is going to move. It is not going to move only there itself. It is not going to move in a circular path there itself, but it will move on a circular path as well as it will be get drifted along B bar. You are able to understand? It will be moving in a circular path as well as drifted along B bar. Such kind of path is what we call as helical path. On the right hand side of the screen, you can see that helical path. Right? So it will be moving in a circular path, and that circle is confined in YZ plane, Y and rather negative Z plane, and even it will be getting drifted along X axis due to V cos alpha. So it will have three components of velocity and three displacements. Two displacements for its motion in a circular path in Y and negative Z plane, and one displacement for its one displacement for its drift along the B bar. So three displacements, three velocities. So we'll try to find out those three also. So this is how it will move on a helical path. Before we go to find that, now there is some distance traveled by it. During a time it complete one circle along x-axis, it will travel some distance along x-axis. It will travel some distance before it completes one circular path. Suppose it started here, ended here, one circular path. Can you see? Completing it here is different from doing it like this. Able to understand? Now, this distance traveled along x-axis during its one complete circle is what we call as pitch. So this particular part is what we call as pitch. This pitch is due to V cos alpha. So this pitch P is equal to, I can write it as V cos alpha into one time period T. So you understood now, there will be X component of velocity, there will be Y component of velocity, there will be negative Z component of velocity. We'll try to find out all the three. Now, to find out those three, first of all, we'll try to find out X, that is displacement along x-axis. Displacement along x-axis is nothing but what? There is no acceleration along x-axis and speed cannot be changed. So V cos alpha into T is your X displacement. And to find out the Y and Z displacements, we'll try to see how does it move in YZ plane. As we discussed, it will move on a circular path along in the plane Y and negative Z. Right? And it will be moving like this. After some time, it reaches here. Right? So it will rotate through an angle theta after some time t. Again, don't get confused. There's an angle of displacement in a time t. So it will be moving like this at that instant. Right? So this will be your Y component Y, and this will be your Z. Okay, R. This total is also R. Now we have to find out R. R will be what? What will be your R? Radius would be how much? Now, what is the force which is responsible? mv sin alpha mv squared by r is equal to qv sin alpha into d. Right? From this, your radius r will become, what radius r will become, sir? Okay, mv sin alpha by qb. Radius r becomes mv sin alpha by qb. Your omega will become qb by m. And your time period will become 2 pi m by qb. So your radius here, try to find the difference between the radius that we found in the previous case. It was only mv by qb, because there the angle between velocity vector V bar and B bar were 90 degree. Now the angle between velocity vector and B bar is alpha. So now the radius becomes mv sine alpha by q. Right? Now, y, your y becomes r sine theta. R is mv sine alpha by qb. Don't get confused with that. R sine theta is sine omega t. And your z, of course, minus z, r into 1 minus cos theta, which can be taken as r into 1 minus cos omega t. Therefore, your Vx becomes V cos alpha, which is dx by dt. Vy becomes r omega cos omega t. And your Vz becomes r omega sine omega t. So your x we found out. X is V cos alpha into t. Your y is r sine omega t. Your z is r into 1 minus cos omega t. So your Vx is V cos alpha. Your Vy is r omega cos omega t. Your Vz is r omega sine omega t. And distance traveled d is equal to distance traveled d is equal to integral 0 to t root Vx squared plus Vy squared plus Vz squared dt. So from this, we can find out the distance traveled d is equal to integral 0 to t root of v squared cos squared alpha, v squared cos squared alpha plus r squared omega squared, because r squared omega squared cos squared omega t plus sin squared omega t will get, which is being 1. So r squared omega squared dt. This will give you the distance traveled. So this is how we can analyze the situations. When theta is 90 degree, how does it move? And when theta is less than 90 degree, how does it move? If theta is 90 degree, it will move on a circular path where radius will become mv by qb simply. And you can find out velocity along x-axis, velocity along y-axis. Don't forget that speed remain constant. That is confirmed. But components of velocity along x and y-axis will change. And if theta is less than 90 degree, let that take that angle between velocity vector and b bar as some alpha, which is less than 90 degree. If it is less than 90 degree, then your particle moves on a helical path. You can see how the edix will be. Right? It will be moving on a circular path in a plane negative z and y. If it is shooted in xy plane, and magnetic field is along x-axis. And apart from moving in a circular path, even it will be get drifted along x-axis, that is along b bar, due to the component of velocity along b bar. This is how a particle will move inside a magnetic field in two different situations. If it is shooted at an angle equal to 90 and at an angle less than 90. So I hope students, you understood the concept. And in the next class, we'll try to see some numericals on this concept. Thank you.